Good morning, everyone. Welcome to the Data Analytics Practice Opportunity Final Presentation 2025-2026. My name is Xinxin Zhang. I'm the Research Data Librarian here at the CUHK Library. I'm delighted to be your host today. We're very pleased to have you with us either in person or online as part of Data Excellence Week 2026. Today's event is held in a hybrid format, streaming live from the Digital Scholarship Lab here at the CUHK Library. In this final presentation session, we'll be showcasing students' data analytics and visualization projects developed using datasets from the CUHK Library and the university collections. This year, we have 15 students who have worked on 6 different projects, exploring and reusing the library's data resources in creative and impactful ways. Before we get started, I would like to invite Dr. Casey Wong from the Data Science and Policy Studies program to deliver his opening remarks. Thank you very much, Dr. Wong.
Good morning, everyone. It is a great pleasure to join you today on behalf of the Data Science and Policy Studies program in the School of Governance and Policy Science. We are delighted to continue our close collaboration with the CUHK Library through the Data Analytics and Practice Opportunity, the DAPO program, which is now in its 5th year. The DAPO program is supported by the university's Research Data Management Project Fund and overseen by the Committee on Research Data Management. Over the years, it has become a valuable platform for students to work with real-world datasets from the CUHK Library's research and digital collections. Through this initiative, students gain hands-on experience transforming data into meaningful projects that highlight the value of thoughtful and responsible data we use. At the School of Governance and Policy Science, the Data Science and Policy Studies program is committed to equipping students with the skills to address complex policy and societal challenges through data-informed thinking. This shared vision has underpinned our long-standing partnership with the library and continues to shape the framework for the DAPO program. Today, we are pleased to present 6 student group projects that have been developed using datasets from 3 key sources, including the CUHK Research Data Repository, the CUHK Digital Repository, and the University Collection. The CUHK Research Data Repository serves as the university's platform for preserving and sharing research datasets produced by the CUHK researchers. This repository promotes the responsible reuse of research data across different disciplines. The CUHK Digital Repository is a one-stop platform developed by the CUHK Library to preserve and provide open access to millions of digitalized scholarly and cultural resources, spanning literature, history, arts, medicine, and more in diverse formats to support research, teaching, and learning. The DAPO program is designed to promote the sharing and reuse of these datasets and digital objects for the public good. The 6 student teams have now reached today's final presentation stage. They will showcase their completed projects, additional project deliverables, including a project webpage, a printed poster, and the programming codes used for their data analytic works will be made available in April. We are also deeply grateful to the invited CUHK faculty and staff members who are with us today to provide valuable feedback on the students' presentations. Your insights are essential for further enhancing the quality of these projects and enriching our students' learning experience. Thank you all for being here today, whether in person or on Zoom. We look forward to an engaging and inspiring session as we celebrate our students' achievements and explore the possibilities that data analytics can unlock. Thank you.
Thank you. Thank you very much, Dr. Wong, for your opening remarks. Thank you again. So as Dr. Wong mentioned, the DAPO program is a collaborative initiative between the CUHK Library and the Data Science and Policy Studies program. Within the library, the research data team and digital initiatives team work very closely together to support and deliver this program. So I would like to thank all colleagues involved for their administrative support, coordination, and behind-the-scenes support. This year's program would not have been possible without the dedicated contributions of our coaches. They have provided students with valuable technical guidance and subject matter insights. We would like to thank all the coaches listed on the screen for their support. Thank you very much. This year, we have 6 student projects drawing on data from 4 data sets in the CUHK Research Data Repository, 1 collection from the CUHK Digital Repository, and 1 collection from the Department of Physics' own archives. A total of 15 students work on these 6 projects. You can find their project titles and the student names and their affiliations listed on these 2 slides, which also indicates the orientation and the order of today's presentations. Team members' names are listed alphabetically by your last names within the team. So I'm going to take some time to introduce each team and their team members. Our first team, Data Queens, worked on a data set examining the impacts of mask wearing, mask use on physiological and psychological outcomes. Both Jin Hefang and Jia Yizhu are final year Master of Science students in the Epidemiology and Biostatistics program. Our second group, LAMDA, consisting of 2 students, worked on a data set exploring latent factors in aging. Liu Yan is a 3rd-year undergraduate student in the Business Administration program, and Asad Yumahabet is a 3rd-year undergraduate student in the Computer Science program. So our third group, Yang Yan, with 3 students, worked on the archives collection of the late Professor C.N. Yan. Kaifeng Deng and Ran Ju are 2nd-year undergraduate students in the Data Science and Policy Studies program, and Chuan Jianxin is a 3rd-year undergraduate student in Government and Public Administration program. The fourth group, Voice, also consisting of 3 students, worked on a data set focusing on patients' voices in cancer immunotherapy. Le Wendong is a 3rd-year undergraduate student in the Molecular Biotechnology program. Shu Mingjiang is a 3rd-year undergraduate student in the Data Science and Policy Studies program. And Hanze Liu is a 2nd-year undergraduate student in the Risk Management Science program. So our 5th group, AC, made up of 2 students, worked on the digital collection of City Entertainment magazine. Ying-Kei Chen is a 4th-year undergraduate student in the Financial Technology program, and Renxin Yang is a 3rd-year undergraduate student in the Computational Data Science program. Last but not least, the 6th group, Twitter Go, consisting of 3 students, worked on a data set focusing on Twitter diffusion. Qishu Guan is a 3rd-year undergraduate student in the Molecular Biotechnology program. Yuxuan Lu is a 3rd-year undergraduate student in the Sociology program, and Miao Ren is a 2nd-year undergraduate student in the Financial Technology program. We're also very delighted to have faculty and staff members with us today who will be sharing their feedback on the students' presentations. We have invited members of the CUHK community to share the feedback on the student projects. Some of our reviewers are actually owners of the data sets used by the students, while some others are connected to the data sets or to the subject matter of the projects. So thank you so much for coming. Now, in recognition and celebration of the successful completion of the projects, we will present certificates of appreciation, certificates of achievement to our students, actually both. We are pleased to invite Ms. Lily Call, Head of Research and Learning Support at the CUHK Library, to present certificates to the first 3 groups, followed by Dr. Casey Wong, who will be presenting certificates to the remaining 3 groups. So we'll proceed group by group. When I call your name, please come to the front here. Each group will have a picture taken with both Lily and Dr. Casey before we move on to the next group. Okay, so for the first group, Jinhe and Jiayi, please come to the front, please. For the second group, Leo and Asa, please come to the front. Thank you. For the third group, Kaifeng Ran and Trang Jian, please come to the front. Thank you. For the fourth group, Le Wen, Shu Ming, and Hanze, please come to the front. Thank you. For our fifth group, Yin Kei and Ren Xin, please come to the front. Thank you. For our sixth group, Qi Shu, Yu Xuan, and Miao, please come to the front. Thank you. Thank you. You can just stay there. We're inviting all students to come to the front now with Lily and Casey to take a picture together. All 15 of you. Thank you. So now we are excited to begin the students' final presentations. Each group will have 16 minutes to present, 16 minutes followed by a Q&A session. To help you manage your time, we'll be using two timer signs, one indicating 3 minutes remaining and another indicating time is up. Please keep an eye on the timer sign here with Natalie in the front. So this is Natalie, so she will be holding up the signs for you. And please adhere to the allotted time frame. After each presentations, we'll have a Q&A session. If you're joining us online, please feel free to type your questions into the Zoom chat box. If you're attending in person, you may just raise your hand and we'll pass a microphone to you. Okay, now let me invite the first group to present their project. Jinhe and Jiayi, please.
Workouts, many people started to worry. Does the mask make it harder to breathe or even unsafe to train at higher intensities? On top of that, we had different mask types, surgical, cloth, and tight-fitting FFP2 or N95 respirators, and people with very different fitness levels from casual exercisers to athletes. But most of the discussion was based on personal experiences, not on solid data. So our motivation in this project is to move beyond anecdotes and systematically look at the evidence. How much do masks really affect physiology and performance during exercise? And does that depend on the type of mask or who is wearing it? Another key reason for our study design is that not everyone's cardiorespiratory system works the same way. Athletes and trained individuals typically have larger VO2 max and can reach much higher ventilation during intense exercise than untrained adults. That means that their lungs and breathing muscles are pushed closer to their limits. So adding a mask could, in theory, affect them differently from sedentary or recreationally active people. By explicitly comparing trained versus untrained subgroups, our meta-analysis can answer a very practical question. Are masks equally tolerate and safe for both everyday exercisers and athletes, or does fitness level can change the impact? Our data set is built on top of an existing systematic review that look how face masks affect exercise in healthy people. That original work put together 45 studies with 1,264 participants, comparing data between mask on and mask off during various types of exercise. Then they conducted a meta-analysis using a random effects model on key physiological and psychological outcomes, such as heart rate, lactate level, SpO2, dyspnea, fatigue level, and thermal sensation. Then let's introduce our method. Our project follows a systematic review and meta-analysis framework, and we are combining results from many similar studies that all compared exercise with a mask versus without mask. First, we went back into the tables and extracted or verified summary statistics, means, standard deviations, and sample size for each study separated by mask type and by population group, such as healthy versus trained participants. This let us fairly combine results across very different protocols. We then used a random effects meta-analysis model, which assumes that the true effect can vary from study to study. For example, between different populations or exercise tests, rather than forcing a single identical effect everywhere. We quantified how consistent or inconsistent the results were using the I-squared statistic and then ran subgroup analysis, especially comparing healthy versus trained participants and different mask types. We also generated a full set of these diagnostic plots, forest plots to show the pooled effect, funnel plot to check for publication bias, budget, and the radial plots to understand the heterogeneity, and bubble plots for simple meta-analysis. The goal of this subgroups analysis are looking at difference by fitness level and mask type to see whether the impact of mask wearing depends on who you are and what kind of mask you wear.
Yeah, so now let's look at the key outcomes that we summarize. So let's first take a look at heart rate. And when we pull all the data from over 30 studies, we can see that wearing a mask does tend to push heart rate slightly higher compared to no mask, but the effect size is small. And when we break it down by population type and mask type, we can see that in healthy populations, respirators does tend to push a heart rate a little bit higher, while cloth mask does tend to push sometimes even lower heart rate. And whereas the trained populations, we can see that trend is more consistent, meaning that there is less variation from study to study, suggesting that well-trained individual does tend to adapt to mask a bit better while exercising. And when we translate this to a larger standardized effect size, we can see that this corresponds to around 3 to 5 beats increase per minute for heart rate, which is not clinically meaningful for most populations in the typical exercise settings. And you can see the key statistics summarized here in this table and their correspondent interpretations. And this funnel helps us to understand the publication bias, whether the positive results gets published. Here we can see this usual spread of small and larger studies, which means that there is no dramatic gap, one-sided gap for heterogeneity, whereas this is a usual spread scatter for the usual pattern for the funnel plot. And here, let's look at the Abbott plot. Each thought compared the heart rate with a mask on, which is on the vertical axis, for no mask, which is on the horizontal axis. We can see that most dots here lies above the red diagonal line, where the mask on effect equals no mask, meaning that in most studies, heart rate is indeed a bit higher with a mask, but again, it's only slightly above the line, so the effect size is small. So our main take-home message for the heart rate is that masks do not meaningfully stress the heart during exercise, and population and protocols included here. And next up, let's look at the performance, which is often the outcome people care most about. In contrast to heart rate, here we do see a clear and statistically significant reduction in performance while participant wears mask. And on the forest plot on the right, we can see that the overall pooled effect size sits to the left of the zero line, meaning that on average, people perform worse with a mask than without. And this pattern is visible in both healthy and trained individuals, suggesting that the performance hit is not limited in one's fitness level. And when we look at the Abbott plot here, this is make it more especially intuitive. Most data points falls below the red diagonal line in contrast to heart rate, which means that in absolute terms, for example, time to exhaustion or distance cover, participants generally do a bit less worse outcome when wearing a mask. And at the same time, there is substantial heterogeneity because performance was measured in a very different way across different studies. And some protocols were maximal, while some of the others are submaximal. The budget plot highlights a few influential outlier studies that use particularly demanding exhaustion protocols or unusual performance metrics. And here we can see a different pattern for compared to heart rate. Here we can see some asymmetry with more studies showing performance reduction rather than improvement, which raises the possibility of a publication bias. Maybe studies showing no impairment was less likely to be published. But however, even accounting for the possibility, this effect of downward trend is still consistent. So we can see here a more robust, particularly relevant downsides regarding performance, especially in settings where competitive sport or fitness testing, this pattern is more obvious. And now let's look at the next outcome, which is the lactate level. Here, when we pull all the lactate data, the overall effect sits very, very close to the zero line, as we can see here, and meaning that on average, the mask itself does not create a huge additional burden on the group level. And when we split the data into healthy and trained subgroups, we can see that in some healthy populations, lactate is even slightly lower with mask, likely because the mask limits the ability to reach absolute peak workload. So the participant may start a bit earlier before pushing it to a very limited zone. And in trained participants, the results are more mixed, with some studies showing a small increase and some decreases, as you can see here. And here, unlike the heart rate plot, we can see the high variability between studies, with many data points are distributed on both sides of the red diagonal line, and with trained participants, which is on the coded in orange, and displaying a more significant deviation from the baseline compared to the healthy group, which is in blue. So, but on average, there is no consistent evidence from this plot that the mask systematically raises or lowers the lactate level across all study. And here, this radial plot highlights a few studies that contribute strongly to heterogeneity, often those with a very specific protocol or measurement methods, with justify why we are using a random effects model. And this also echoes with the forest plot pattern we can see before. And overall, masks do not consistently cause a large extra metabolic stress. The individual studies may vary, but at aggregated level, we do not see a strong uniform shift in lactate due to mask wearing. And now let's look at some of the psychological outcome, which is rate of perceived exertion. This is often captures how hard the exercise feel on a participant's perspective. Here, this pattern is much more clear. The pull effect sits well to the right to the zero, meaning that across studies, participants consistently reported higher perceived exertion while wearing a mask compared with no mask. And this is true in both healthy and trained participants. So the subjective feeling of extra effort is quite robust in our study. And for data visualization, since there are multiple scales across studies, some use broad 10, broad 20, and broad 100 to see the effect, we decided to standardize them to Borg 100 to allow more accurate display of the effects. And this level plot makes it very intuitive, is that many of the data points lie above the red diagonal line. So which means that for the same type of exercise, the rate of perceived exertion score are higher when masked. So even if objective physiological outcomes like heart rate is small, this people feel that the session is more demanding. And here, this bubble plot helps us to check for bias and whether higher baseline of effort magnifies the perceived discomfort. So here we can see a negative slope in the bubble plot, and this reflects that the mask has its more pronounced effect at lower intensity, whereas the difference between the conditions becomes almost legible as like the physical intensity increases. And this might be due to a ceiling effect. But however, for overall conclusion is that exercise with a mask feels harder, especially at lower exercise intensity. And finally, let's look at SpO2, which is the blood oxygen saturation. So when we pull all of the available study, we can see a small but statistically detectable reduction in blood oxygen level where participants exercise with a mask compared to no mask. And when we look at the Ablet plot, we can see a consistent decrease where a lot of the data points lies below the red diagonal line. And when we look at the budget plot for heterogeneity, we can see there are a lot of substantial outliers, meaning that the collection method might be different and they're but pulling this all together, this suggests that while mask can slightly reduce oxygen level, the population settings and the population we analyze, the reduction is small and typically still within the safety limit. And now let me conclude by stating a few limitations for our study. So first, we can see that a lot of studies don't include individual data and they are more male dominated. So which means that we can only look at this from with a male population. And since we are unable to get the individual level data, we can't do a subgroup by gender. And the second limitation we have is that there are high heterogeneity across studies, which means that across the budget plot and radial plot that we see, there are a lot of scattering. And lastly, because we are limited in studies, some of the outcomes highlighted in the original article, which means include like thermal sensation, etc., because there is a limited subgroup, therefore we cannot do a subgroup analysis. And finally, this only applies to a short-term lab setting exercise, so it may not be applicable to long-term in a real-world setting. And in conclusion, we can see that there is a significantly decrease in performance and SpO2 and etc. However, there is no statistically significant increase for heart rate and lactate level. And the overall key outcomes are summarized here. And since we are, I want to emphasize that since we are limited in a study and population size, so this the effect size of the overall study is still limited, and we'd like to a further investigation if we are looking at subgroup analysis. And so that is the end of our presentation. Thank you so much for listening and welcome.
Thank you. Thank you very much, Xinhe and Jiayi, for your presentation. So do we have any questions for this group? Please raise your hand and we'll give you a mic, or any questions from the online audience, feel free to type them into the chat box. Yes, Professor Pon, please. The mic is here. Yeah, thank you.
Okay. Yeah. Hello. Nice to meet you. Right. So, actually, this is I'm one of the authors of this paper, and yeah, and I think you have done a very good job in running again our data. So, I just have a quick question. Because for one of your major outcome here is the subgroup analysis between the well-trained and the healthy individuals. So I just wonder how you define this well-trained and healthy, right? So do you read all the individual primary studies on your own and you define it, or actually this is based on the because I can't remember whether the original authors have defined well-trained versus healthy. Yeah.
Yeah, thank you for your questions. So we actually gathered this data from one of the summary tables that the original article has. So some of them are classified as healthy individuals, some of them are classified as sedentary. We also went back to the primary study to check that actually correspond to their own definition, while some of them are actually trained athletes, or some of them are, well, there are various type of sports, but since that we're considering on a general level, we consider them as fit or trained individual, if that answers your question.
Yeah, thank you. Yeah, because I think maybe for this point, you may want to give a more precise definition because somehow the so-called the well-trained people, so we may also think that they are healthy. You see my point, right? Because healthy and well-trained somehow they are not mutually exclusive. So I think there should be like a there should be some kind of like definition. I mean, yeah, in your analysis. So yeah, this is just my thought. And maybe just one quick maybe comment is I suppose for the force pod, right, is all the force pods are made by your team, right? So because it doesn't include in the original study as I just double check. Okay. So but maybe my suggestion is because I do notice that you maybe for some of the numbers or the values, so you have put in like quite a number of like decimal places. Like maybe you can just go to any one of the force pod like. Okay, yeah, like this. So maybe for my suggestion, like maybe for the standard deviation, so you may not need that much of like decimal place, the 0, 0, 0. So yeah, that may help you improve the clarity of the of this visualization a little bit more. Yeah. So yeah, this is my little comment. Okay. Yeah, but overall, I think you have done a good job.
Thank you so much for the fun. Thank you very much for coming. Thank you. Thank you so much. Any other questions for this group before we go to the reviewers' comment? So now I would like to invite Ms. Jiaqi Zhang, a PhD candidate in the Department of Sports Science and Physical Education under the Faculty of Education to give a comment based on the student presentation. Thank you very much, Jiaqi.
Okay, thank you. Thank you, Qing, and thank you for inviting me. And thank you for your all putting together this presentation. And I can see you've done thorough research on this topic and compiled a lot of valuable information about exercising with masks. So actually, I have two questions and one small comment that will help clarify clarify the practical implications. So what will you say is the key takeaway message for those of us who need to exercise while wearing a mask? So if someone has to work out with a mask on, what is the most important thing they should know to do to exercise safely and effectively based on your research?
Yeah, so I guess the first question is for our study, our main take-home message is that there's actually although we can see there is a statistically significant reduction in performance or rate of exertion, that all of the physiological outcomes are not significantly affected. So I guess combining all of the two questions together is more like although we know that it's more difficult to wearing a mask, but it's also important to know that there is actually no physiological outcome associated. So you're still safe while wearing a mask. So I think that clarification will help you feel a little bit better, knowing that it won't actually physically affect you. So I hope that it potentially decrease your rate of perceived exertion as well, while having that idea in mind.
Okay, thank you for your answer and take-home message. And I also, what's the second question is that could you please go back to the regression line about the RPE? So one question regarding the statistics, the next one. Yes, I noticed that you improved according to the last comment that because I mentioned that they have different RPE skills. So you just standardized it. So you perform another regression test right now. So we can see a negative slope here. So I was wondering if there is any significant regression coefficients for this regression analysis. So if the beta, the regression coefficient is significant.
Oh, I think this bubble plot, because it's not, we haven't done a official formal meta regression. This plot is more like actually showing the downward trend. I don't think we generated a beta for or the coefficient for the graph.
Okay.
It's more like showing the overall downward trend. But if we were going to do a meta regression in R or SPSS or similar software, we can gather a more informative coefficient that we can potentially include in our website or poster.
Okay, thank you.
Thank you.
And one final comment is that I think there is duplicate forest plot for the performance and the heart rate. So the two photos are identical. The forest for heart rate and the physical performance.
Oh yeah, we will definitely correct that when we are making the poster or the website.
Thank you.
Yes,
That's one thing that is.
yeah, we might have missed it when we are getting the presentation. Thank you so much.
Thank you.
Thank you. Thank you so much, Darcy, for your comments. And thank you so much again for our first group presentation. Thank you again. Please take a seat. Thank you. So now let me invite the second group, Leo and Asa, to come to the front. Thank you.
Morning, everyone. My name is Asad, and I'm year 3 computer science student. And this is my teammate, Leo, year 3 business student. And whenever we think of our birthdays, we think of it as a starting point to count our age. But what if we tell you that this is not always biologically true? And today, our team will try to investigate the latent factors that make you age. And specifically, we'll try to go through our data set to find the variables that might affect your premature aging, as well as try to use this data set as somewhat clinically important data set to predict the biomarkers that are responsible for aging and detect anomalies in case there is an anomaly. Okay, so this is just a brief overview of our data set. The data set itself, called Moderate Vigorous Physical Activity Attenuates Premature Senescence of Immune Cells in Sedentary Adults with Obesity, a pilot randomized controlled trial. So essentially, the data set consists of 45 patients that are in the obesity group in Hong Kong. And we're given biomarker values for each patient. And biomarker value, if you don't know, is essentially protein amount in the body. Specifically, we'll focus on P16 and P21 biomarkers that are somewhat responsible for premature aging among people. And then we also go through the variables that are given in a data set, such as demographic variables, anthropometric variables, physical activity related variables, and etc. And we're also given, because the experiment itself was done to around 15-ish people, and there was also a control group with also 15-ish people. And essentially, the intervention experiment was done on the people to see whether the moderate to vigorous physical activity has an effect on alleviating the premature aging process in the people within the obesity group.
So today we'll be talking about 3 main questions. The first one will be estimating the biomarkers in people. So if they don't know the biomarkers already, how can they use their existing factors in their body to predict what their biological aging is like? And then second is, once they know their biomarkers, how can they find out if they are part of an anomaly group compared to their peers, or how do they know if they're normal? So we'll use anomaly detection for that. And then finally, we will use the intervention data to find out that if they are concerned with their aging process, or if they are at risk of premature aging, how can they use different factors to help them reduce or reverse the effects of biological aging, and how can they measure their progress as they go on as well without going through another test. And we will finally have a conclusion Q&A at the end as well. So first of all, we will look at estimating their biomarkers using factors they already know about their body. And we will mainly be using correlation and linear regression for this process. So first, looking at our data sets, we can see that first of all, we point out that this data set is all for an obese group. So the BMI is all around 30, which is classified as obese. And this data set is only targeted to this group, so it wouldn't really be applicable to people who are outside this BMI group or in different demographic groups. And we can also see that for a senescence biomarker group, which is for one measuring their aging, the age range is actually quite big on this data set. So there's a lot of interpolation between age groups, and we can't really draw any clear conclusions from the age itself. And finally, we would also like to look at the activity metrics of this group. So their VPA, first of all, is quite low in general throughout the whole group. This would be around 5 minutes per week of activity, vigorous activity for the group. And we won't be able to use this variable as much, but then we can use MVP and LPA instead to measure the activity throughout the week. And then looking at the correlation. So first of all, we can see that there's a lot of correlation within a group, like within each category. So for the biomarkers, their behavioral and their anthropometric measures, there's a lot of multicollinearity within these groups, and we won't be able to really draw any insights while looking at these group relations. But then we can look at the ones for the biomarkers related to the other groups. So for P16 and P21, we can see pretty high correlation amongst BMI, waist, MVPA, and steps. And we will be mostly using these factors as we go on as well. Okay, so just looking at the scatter plots for the correlation between P16, P21, and the remaining factors. So first looking at the other biomarkers, we can see that there is some sort of correlation between P16 and the TNF-alpha and IL-1 beta biomarkers. But there surprisingly is no correlation between P21 and these biomarkers as well. And we can go on to see for MVPA, steps, and waist, we can see there's a noticeable inverse relation between P16, P21 with these groups. And surprisingly, there's also an inverse relation with waist as well. So technically, the greater the waist size, the lower the biomarkers as well. But we will explore this further in our regression. So when looking at regression with the individual variables for each of these biomarkers, we can see that BMI, MVPA, and steps remain the most significant predictors individually of these biomarkers for both P16 and P21. And we can see that VO2 max and DBP are also closely significant with these biomarkers as well. But then if you want to look at combinations of these variables, then we can go on to try out different combinations, and we can see that within these combinations of these are ranked by the most amount of significant variables within a regression, and we can see that weights, DBP, waist, steps, and MVPA occur the most amongst these regressions, and usually they will result in individually significant and model significance regressions. And when playing around with these variables more, we can finally result in our model that can help estimate people's biomarkers with their own body measurements. So the first could be with their blood pressure, waist, weight, and MVPA. We can see with these models, almost all variables within these models are significant for both P16 and P21. And we can also see that, interestingly, age actually plays basically no role in predicting their biomarkers in these models. And that's basically saying when you're taking into consideration their movements and their blood pressure and their physical health, actually age doesn't really play a big role in their biological aging compared to their other factors. And this is also consistent with the findings in the paper that accompanies this data set, and that MVPA remains the best predictor for their biological aging in general. And just looking at the residual analysis for our regression models, we can see that for the P16 model, there is the residuals are mostly normally distributed, and there is little correlation outside of the model. And to talk about anomaly detection, I'll pass it to Asit.
Thanks, Leo. So Leo just showed us some regression analysis of our data set in terms of what kind of variables might have some high correlation with the P16 and P21 biomarkers. And now it's within our objective to also use data set to build a regression model that might be useful within the clinical context. So we will use the regression model to predict P16 biomarker based on the variables we have, and then use this expected value that is yielded by a regression model to see whether the user's input has some anomaly in terms of whether their P16 biomarker is too high, so they are at risk of premature aging. So we used different regression models, including linear regression, random forest, decision tree, support vector regression, etc. And we also used a pipeline to see which regression model performs relatively the best in terms of the R-squared score. And we also split our data into 70% to 30% ratio. And yeah, we use R2 score and MSE scores to evaluate the performance of our model. And we come up with very interesting finding that linear regression, despite being the most basic model out of all, still perform relatively well in terms of the R-square score compared to other models, which we somewhat think is because our model has only 45 patients. So other models that are more complicated or advanced might have the problem of overfitting with the given data. And so we will choose from onwards the linear regression as a model to predict by P16 biomarker. And then we also went through select best key features for our models. And you can see the word cloud where slightly bigger words are the variables that are chosen most frequently by each model in our pipeline. And if we go to the next slide, we can see that linear regression as the best performance-based model chose these specific 4 variables that are very good at predicting and explaining the variance of P16 biomarker, namely MVPA, TNF alpha, waist, and BMI, which also somewhat aligns with the findings that Leo just showed us. And this is the line of best feed over regression model. You can see there's mostly inverse correlation between P16 and the PCA result we had. And yeah, and you can see that although there's a lot of bias in terms of like plots and in terms of the points, but we still somewhat can see that it is a line of best feed essentially. Yeah, and now for the anomaly detection, we were thinking about this and we come up with this very interesting concept called student residual, which in statistics is used to detect whether the point is called influential or point that might be an outlier in the data set. So essentially we take a deleted residual or the residual of the point that we're trying to investigate and divide it by its estimated standard deviation. And its value can tell us whether the point is influential. So it can pull our regression model and change the line of best fit, which essentially means that it is influencing the line. So if the student's residual of the user's input is more than or equal to 3 or 3 standard deviations away from the line, then we can essentially say that it is an outlier. So it is an anomaly. And so we will use the residual between the user's P16 value with the output of our model to predict whether the user is actually at the risk of premature aging. And so this is our implementation of the data set we have in terms of anomaly detection. As you can see here, it says anomaly status is true, meaning that the user input, which we also kind of created randomly, meaning that the user is at the risk of premature aging. So doctors or people who use this model can essentially use this data, use this model to somewhat predict if the person is at risk, which we think is clinically useful. Okay. And then we also try to run KNN regression, but then we come up with this problem that it's actually not good because as you saw in the previous slide, the data points are very close to each other. So we tried to still use KNN clustering to come up with some interesting insights. So we ran the model through different features with P16 biomarker value, and then we use silhouette score as a way to evaluate whether there is a specific K value that is the best in terms of how close it is to its own cluster and how far away it is from the other clusters. So we maybe can come up with some interesting insights. And so we found out that when we ran the clustering on P16 versus all the other variables, although that does not look really nice because again, it's all the variables. We also saw something interesting, which also kind of aligns with our findings, is that the yellow highlighted fields is 2 groups that are somewhat close to each other in terms of most of the variables. But then the MVPA is very significantly different. And the cluster group that has lower MVPA has much higher P16 biomarker value, which essentially signals us that MVPA is a very strong variable to say that P16 biomarker is inversely correlated with MVPA. And also another interesting finding is that the cluster with the mean age of 22, which is the youngest group in our data set, is the unhealthiest one among all other groups, which is quite concerning. The next one is the cluster with P16 versus MVPA, where we can see that in the green highlighted area, the sleep duration can somewhat have some effect on the P16 biomarker because essentially those two clusters are quite close to each other. But despite the third cluster having slightly more physical activity rate in their daily lives, they still perform relatively poor compared to the cluster number 0, which might be because of the sleep duration again. And we also found out that the waste has, again, a significant impact other than other variables on the P16 biomarker value, which you can see in the yellow highlighted fields. Okay. And then for the clustering P16 versus STAPS, we can see that, again, sleep duration and blood pressure might have some effect on the P16 biomarker values despite the MVPA, which might be investigated further, whether lifestyle, which is stressful lifestyle, might affect premature aging among people. Okay, and TNF alpha biomarker, as we can see, has positive correlation with the P16 biomarker value. And if you see the size differences, the size is essentially MVPA variable. So the more you're physically active, then the less likely you have a high level of P16 biomarker values. And also, yeah.
In the interest of time, I will go through this section a bit quickly. So first of all, we look at the intervention data sets, and we can see that the intervention group after the experiments had significantly higher movements in terms of MPA. And for VPA, it was already really low in the beginning, so it's pretty skewed in terms of their difference afterwards. And we can see that there is significant difference between for P16 and P21 in the intervention group during the after the 3-month program. And interestingly, the other biomarkers did not have too much of an effect. And we can see that the thing that changed most for these groups was waste and VO2 max. These were the ones that were able to be impacted most through more movement. But also interestingly, we can see that weight, fat, and BMI were not really affected after a 3-month movement program. And then finally, we can see that when predicting the change of P16 and P21, waste remains the best predictor, though this can't really be drawn through to definitive conclusions because of our small sample size and our very varied data sets with no matched observations. But yeah. Okay.
To conclude, essentially, we're saying that chronological age doesn't have really effect on the P16 biomarker premature aging process, but there are other variables such as physical activity that do have effect on that. And we also try to find some interesting findings in terms of how other variables such as sleep duration can affect on the premature aging, and so yield the path to future developments in this field. And we also provided model that can be clinically useful for doctors. So now Q&A section. Thank you.
Thank you very much, Leo and Asta, for your presentation. Thank you again. Do we have any questions from the audience, please? Yeah, Jiaxi, please.
Okay, thank you for your presentation. Actually, I have one question regarding the biomarkers. So for those P16, P21 order interleukin something, you are measuring, it's actually the protein level or the mRNA expression level?
It's a protein level, but it's like log value. So that is going to
So
be.
it's running by ELISA, or you do some reverse transcription and do the mRNA analysis? So I'm not sure it is actually the protein you are measuring, or you are measuring the mRNA expression level that is using another technique.
We're not quite sure because it's taken from the paper and we're not really from biomedical science background.
Okay.
But, I suppose it's a protein level because that's how they refer to in the paper itself.
Okay, thank you. So also another question is because I noticed that all the data are quite correlated with each other. So you may not have find some machine learning techniques quite helpful in dealing with data sets, these kind of data sets. So I would like to suggest you would like to try put the data into a higher dimension to put a kernel into your data set to try some like kernel partially square regression. Yeah, that may help to identify the shape of the data.
Thank you.
Thank you.
Thank you. Now I would like to invite Professor Eric Kwong to give some comments based on the presentation. Thank you.
Okay, yeah, thank you for this group's presentation. So I think it is really insightful, right? And to be honest, I'm not an expert in data science. So, but I do understand that you have used many like novel and more advanced technique in running the data. I think I just want to go back to some like basic questions. So for this particular study, because I'm not the author, one of the author of this study, so I just wonder how many subjects or the sample size for this particular.
The sample size was 45, and then in the intervention it was 14 control and 14 intervention and 15 control.
All right. So when you're running like maybe the linear regression model, so do you think like this sample size 45 is able to really justify the correlation that you found out, like because maybe I noticed that you have run like some regression model and you have like put in like different so-called independent variables there. So yeah, what's the comment? Because I remember in one of your slides, so you do mention that maybe you can go to the regression analysis. Maybe I think at the first few slides. Yeah, and maybe the one before. Yeah, like this one. So how strong, right? Like, do you think you can conclude like about the correlation, okay, of like the MVPA and I mean the health outcome versus the biomarkers?
So for that point, we can see that visually we can see there's some correlation, but then when we're running the regression, especially with many variables, we try to limit as many variables as we can and only limit to statistically significant variables, because we understand that with this data set and there's not too much correlation, there's not much data points that can show the correlation between other variables with one variable Held constant because of the limitations of the size. So we just try our best to limit the amount of variables we choose and just try to choose the most significant out of all of them.
Right. Yeah. So yeah, this is my concern, because somehow, right, so when people say they find like a correlation, then my first question is how robust, okay, that your data set can really like tell you, right? So this is my question. I mean, but I do understand that, right? It's not your fault, right? It's mainly about like the limited sample size of the original paper, right? But just maybe bear in mind, maybe in the future try not to overstate too much, okay? Maybe for your conclusion. So this is my first comment. And another maybe minor comment is because again, because for us we are from exercise science, and somehow we also want maybe our message to be like more practically being disseminated to the public. So I noticed that for your group and also the previous group, somehow when you present, like I remember in one of your summary table at the very first slide, summary table, like this one. So now my suggestion is, I'm not sure, is this table made by your group or is it from the original paper?
I just made this table from the data set that's provided.
From that means you make this table, is it?
Yeah.
Oh, okay. So then maybe my suggestion is like maybe when you present some numbers like the age. So usually we don't expect the age to be presented in like 3 decimal places, right? So when we come to the case, so I'm like 33 years old, 34 years old, and I won't tell people I'm 31.711 years. So you see my point. So yeah, because we are like applied scientists. So somehow at least for myself, so I value like this kind of like data communication a lot, right? And so just bear in mind, right? So okay, so yeah, but other than that, as Vijashi mentioned, so I think your group has done a very great job, right? Okay, very interesting analysis. So yeah, gained a lot of insights. Okay, thank you so much.
Great, thank you so much, Professor Arapin, for coming. Yeah, thank you so much for coming and for your review and comments. Thank you again for our second group. As and Leo, please take a seat. Now let me invite our third groups to come forward. Kaifeng Ran and Chuang Jian. Thank you.
Good morning, everyone. Today we'll be demonstrating our reconstruction of Professor Xian Yang's Transpacific academic network history. Basically, we're trying to explore how Professor Yang, from correspondence to co-authorship, and through that, we want to explore his professional network. First is a table of content. We'll give you a background information of the data set, and then clarify our research question, and then the 3 phases that we have done to approach to this research questions, and conclude with some further insights. So first of all, the background information of this data set. We're very grateful that the CUHK archive stored in the physics department provided us with the archive of Professor Yang Chening. So Professor Yang Chening is someone I think we do not need much introduction. He's someone who grew up in the wartime China, went to the US in the 1950s, got his PhD in University of Chicago, and won his Nobel Prize in Physics in 1957, and then returned to China in 1971 and stayed between Beijing and Hong Kong later then. And here is an overview of the provided data set that was given. So there are a total of 1,283 observations, and the given definition of all of the types are mainly articles, notes, and notebooks, and then a lot of photos with some small amount of correspondence and media materials. Now, with the given data set, we are trying to look for, over the period of cover out in our data set, how does Professor Yang's professional network measure through co-authorship, correspondence, and co-mention change over time? Underneath that, we also have two sub-questions. Do pre-specify Professor Yang's milestone and China's-US relations phase coincide with the structural shifts in these measures? And the second would be, do temporal or cross-border pattern differ systematically across the three layers that we are trying to measure? The framework that we're going to use is the network analysis, which is something that is quite established and famous in the field of sociology. So the node and vertices, meaning it's the individual of Professor Yang and all other scholars or entities, were measured through the time of year, and the affiliation is by country and by institution. So as we introduce, we'll also use three-layer, meaning the multiplex ties and edges across the entire research. So now, before we do anything, we need to do data pre-processing first, and we have to understand what is the data actually look like, and then clean it for our later analysis. We want to look and further and double check whether the given definition is exactly as it said. So we look into it, and we found out that actually the co-author articles has predominantly handwritten notes, such as ones in here. And even though the correspondent initial definition was 16, but we were able to find 89 that provided us with more resources to analyze in the future. And the co-mention we found is mostly comprised of the photos Professor Yang taken. Now, with that definition, the new definition, and the new resources found, our team's aim at phase one is to turn these raw and manually input data set into an analyzable data set to serve for the research question. I'll leave Kevin with the first co-authorship layer.
So continuing from what we outlined earlier about the data sets, one change we face is the incompleteness of the co-authorship information in the given archives. So to address this gap, we try to utilize the public available data sets, the Google Scholar and the Inspire Hub. And we try to add these two data into our data set to enrich and validate our data through cross-referencing. And as we know that Google Scholar is one of the most comprehensive academic research engines. It provides us a broad view. And for the Inspire Hub, it's an open access platform specializing in the field of physics. And how do we combine the platform through cross-referencing? We first initial research and make the data connection. And then we consolidate the data by the Python. And the last one, we make the validation. And now I will leave the part back to Justin.
Yeah. And in terms of, here's the EDA of the co-authorship. And in terms of the correspondence, because initially it was 16, but after our manual identification, such as we did a keyword search and human inspection one by one of the scanned PDF, we checked that there's actually 98. And later we used the data from the given data set. For example, in Python, we did data manipulation as well as the duplication. For example, Professor Xian Yang could be also called Franklin Yang and Yang Zhening. And then we label it with institution and country with the help of AI. And here's the EDA, and we can also see for example, the correspondence per year, which individual they're from, and which country they're from, and etc. And I'll also let Laureate to introduce comment.
So I will introduce the convention part, which mainly uses the photo data set given by the library. Thank you for the library, because the data set is very clear, but we also need to do further work. So we need to recognize the text in the data set and put the different data divided into different columns. And in fact, we use the similar method and approach with the last part, like the data population. I can give an example, like we must make sure the CN Yang, Flucalin Yang, and Yang Zhenying in the same entity. So after processing is our clean data set, and this table is one type of the example of our convention clean data set. At first, we use the OCR extraction to make sure we have different columns, fields, and after that, we use the geocoding to get different location and different longitude and latitude. Finally, clean it, and we get a clean data set. You can see the table column is about time, location, different people, description. And this is an easy table, a simple table about our clean data set. We counted the top 5 locations. It means that CN Yang takes the most pictures there. It's very interesting that you can see this is Beijing, Hong Kong, Princeton, and it has different location, different country. So this all work about the processing.
Now on to the data analysis and visualization. So what we have done for after we have cleaned the data. So this is like a brief, like a graph of the social network analysis to make it clear that we're using it as an exploratory purposes only. We're not trying to use it as to see the bridges and brokerage as the data was not available at this time. But you can see briefly from this graph, the width and the proximity of this different individuals towards Professor CN Yang, meaning that there's tight strength between these individuals. And we'll also use other graphs, for example, use cumulative network growth to measure and to see the temporal change of Professor Yang in these 3 layers across time, as well as the temporal change of the network activity across time. The layer, for example, which are the who he mostly co-authored with, the correspondence with, and the photo that he has taken over his lifetime. Most importantly, we also have a CUHK similarity, which is trying to see the overlap between these layers. We can see that co-authorship and correspondence have the highest, but overall, there isn't much overlap. We'll elaborate this implication in the next section, as well as we also did a tie strength. So for example, which individual who has the highest tie, connection with Professor Yang. For example, the first one is Professor T.D. Lee and then T.D. Cho, and we'll also give more elaboration further. We also combine it with time, for example, who has the highest high strength, and also across the period of time of duration. For example, mostly of them are less than 10 years. Some of the family members are over 60 years, and there are also some of his colleagues spanning from 10 to 50 years. Now, something interesting that we have done is the interactive map. I'll let Kevin and Laureate to introduce further.
So this interactive map visualizes the global correspondence of Professor Yang from 1951 to 1993. And this group allows you to explore the geographical connection directly, where the brightness of lines reflect the volumes of the connections. And then you can filter the timeline to see Professor Yang correspondence in different times. And the statistic summary here, you can easy to see its location, correspondence, and connections.
Okay, next, the next one is convention interactive map, and it's also ours. And we called it Yang Zhenying Life General because you can control the timeline like this one. You can control the timeline and following the shining spots. to expressing the Xing Yang's whole life according to the photo data set. And also you can click in the location. You can see that it's about the location, time, and the description of photos. In fact, this square is the location. We can put the picture there, and in the future, if we can use the CO library server, we will perform our photo there. So that's all part about our Intel map.
Okay. Right. Okay, I'll just do it. The phase 3 is the findings and implications. What have our analysis have answered the research question and maybe giving some implication beyond? So first of all, the first question, research question 1, how does Professor Yang's network change over time? I think we can divide it into 4 phases. From his first 1922 to 1949, most of the photos that he have taken is in wartime China, meaning a lot of the connections with family members and his early education. And in 1950 to 1971, when he was in the US, this is one of the most structurally dynamic period, as you can see in the time when he was in Princeton since 1950. There is a most productive period of time peaked at 1952 to 1962. And then later on, you can also see there's 48 new correspondents entering this network at this period of time, signaling that when after he won the Nobel Prize, for example, there's an increase and a peak in the amount of network that he have further gain at the time. However, after 1971 onward, there is a visible reorientation in the network or geography. For example, in the phase 3, you can see the photo convention exhibit a marked increase in the China-based connection. And also later in the secondary peak, you can see in phase 4, which is around late 1990s and early 2000s, there is also an increase when he was in Beijing, Tsinghua University. Then also the milestone and geography alignment at the time. So our finding actually supports the alignment across multiple dimensions. For example, when probably the most significant milestone is his Nobel Prize at the time. You can see there's a spike in the knots and edges of the correspondence, especially in his network in the US, as well as other countries. And also when there is the 1971, when he returned to China, as well as President Nixon visiting China at the time, there's a spike in the China-based convention. And also 10 years after the reform and opening up, there is also a surge in the China-based convention. There's also a cross-layer differentiation. So you can see there's a distinct social world where there's not much overlap. So the coauthorship mainly is in the US, correspondence. There's a border disciplinary and institutional scope, meaning that there is a border connection rather than in the US. And most of the photos are family members, political figures. And so you can see the social world of Professor Yang is also wider than the co-authorship. However, there are 3 exceptions. First is Professor T.D. Lee. He's at extraordinary high composite tie strength to co-authorship. And also Professor T.T. Cho, who is a professor in Ohio State University, had a sustained but lower intensity co-authorship relationship spanning a longer time period. So it reflects a longer but perhaps less intensive productive partnership with Professor Yang. And Professor Tai-Chun Wu, a professor in Harvard University, a dominant knot in the correspondence layer and significant in co-authorship as well. He's arguably Professor Yang's most multiplex author, engaging with Professor Yang across multiple social registers. So what implication do we have from our study? First is for the historian of China science, the temporal alignment between Professor Yang's personal network and the phase of US-China diplomatic relations suggests that the history of China's physics in the post-Mao era cannot be told without attention to the network structure that Professor Yang's long history in the United States had made possible. And also for the sociology of science, we can see that most of the large-scale science studies that rely solely on co-authorship is something that could be further improved, as our study improved that the cross-layer overlap could challenge this single channel view of scientific network formation. And also for archival digital humanitarian methodology, perhaps in the future opportunities, the project could highlight the potential to achieve this work that need considerable labor require reconstruction. As well, we are seeing that the methodological pipeline from web scraping to the geocoding is applicable to other similar archival collection as well. And last but not least, we believe that the future studies based on this could further examine Professor Yang's bridge and intermediary by identifying the Professor Yang's bridge across the 3 layers sequentially. And that'll be all for the presentation that we're presenting today. Thank you very much for your attention.
Thank you. Thank you very much. Thank you very much again. So we're so glad to have Professor Pao Hui here with us. I know that you're under the timeline, so I would like to give you the mic and
But I really didn't expect that I need to say something.
Thank you.
I was just invited to come. So first of all, I think you touched a very good topic. So you define the problems very nicely. However, I'm a little bit disappointed. Maybe you are too ambitious. Well, I think just like the other talks that I heard, there's so many charts, so many pictures, figures, things like that. It may be more useful to be more focusing on, say, one question that you want to answer. Actually, at the beginning, when I heard of your stated questions, you try to define the problem, I was thinking, maybe if you got some good results, that may be publishable. Because history of science or history of physics is a research area, actually. However, I think it's still a long way to go. And you are using network science technique. I happen to have worked on that as well. That has migrated to social networks, so in the other things. Now, first of all, Professor Yan's life is coupled with the history of modern China. That is closely tied. So we really need to study side by side what happened in China, not only the Sino-US relationship. Because if you think about why did he get the scholarship, that has to do with Tsinghua, and then what kind of work he did for his master's, even undergraduate projects, master's and PhD projects in Xinan Nenda. And then why did he have to go to Chicago? And why did he go into theory instead of experiments? Okay, and then how could he team up with Li Zhengdao for his work? And then in his brilliant years of 1950-something, and actually he contributed a lot in 3 different areas of physics. So I was thinking, for example, you just take a whole full list of Professor Yan's publication list, and you don't need any data set. You just look up all the papers, and then you have coauthorships. And at that point, you already could develop a temporal network centered from at CNN, and then you have Wu Dayou, his master's degree supervisor, and then T.D. Lee. Then you could project a very beautiful picture of how this coauthorship network evolved in time. And there are multiple co-authorships between 2 authors, and then that line could be thicker. And that will be a very clean and beautiful picture. All right? And you must also understand that Professor Yan is not someone who worked with many other physicists. his mind is too quick. It's very difficult to catch up. If you look at his whole life, I think he seldom had any paper more than 3 authors. Okay, so it's kind of a lonely guy in modern physics. So he's a very different type of physicist. And I think some of your analysis, this coauthorship network, for example, could illustrate that. And he is not someone with the modern standard that published many papers, but everything he published was good. Right? So that you can contrast with some modern physics authors. So and then you could present something more basic, like I don't know, those links. What do you call it? Degree, and then some cluster. Whether your friends are also friends of each other, etc. Those clustering coefficient, etc. So I would say you got into a very good archive, rather unique. And I'm glad that someone is using the materials in that archive. So it is a precious amount of information there. I'm glad that you start to dig into that the materials in that archive. And I think there are good elements in your defined problems, but it is too ambitious that it becomes spread out too thin. Okay, so maybe you focus on something and then present your results in a more systematic way.
Thank you very much for Professor Hui's comments. I think Professor Yang is definitely a giant in the field of physics. I think even you give us 1 million data sets, 1 million observations, it's very hard for us to really conclude every detail and trying to find every spot of Professor Yang. But we acknowledge that there are some, for example, we could perhaps in the future studies could definitely narrow down into one specific field.
You might have already detected that maybe into the 1970s or 80s, he started to write about physics instead of publishing original results. Yeah, so actually he taught a few courses here. And then I sat in one of these courses. And then at that time, it is already 2000 something. Okay, so he became the only person alive who had met Einstein, Heisenberg, Schrödinger, all those people. It's the only living person. And then he brought up these wonderful stories. So you may find a particular year as a line. Before that, he was publishing his scientific achievement. And after that, he was writing about the story of physics. And those are also wonderful stories. And they are different kind of publications.
Okay, very much for the insights. Thank you.
Thank you very much, Professor Hui, for coming in the midst of very busy schedule. Yeah, really appreciate all your comments. And do we have any other questions from the audience, maybe online or no? Okay. All right. Thank you so much again for our third group. Thank you, the Yang Yan group, for your hard work. Thank you. Now let me invite the fourth group to share the project. Lowen, Shuming, and Hansa, please. Thank you.
Beyond the noise and hear the voice. Good morning, everyone. We're Team Voice, which stands for the views on immunocancer engagement. I'm Hanze, and with me are Shuming and Lowen. So today our topic is analyze the patient voice in cancer immunotherapy using NLP. So first, let me introduce our dataset. The dataset was created by Professor Cheong. It contains 5 million posts from Cancer Forum on the Facebook, Twitter, and Reddit. So the posts were collected from 2002 to 2021, covering the full patient journey from the diagnosis and treatment to the survivorship and even the daily life. So our research objective is the perception of online communities towards the use of cancer immunotherapy. The reason why we focus on the online communities because there's where the patient can speak freely. And our objective value is twofold. First, to review the critical gap between the public opinion and the scientific literature. Second, to provide actionable insight to improve healthcare communication strategies for the hospital and the doctors. Here are some research methodologies. So first, let's start with the good news. In 2013, the Science magazine named Immunotherapy the breakthrough of the year. We've evolved from the early cytokines to checkpoint inhibitors, the CAR T cells, and vaccines. In previously untreatable cancers like the metastatic melanoma, long-term remission is now a reality. Thousands of clinical trials are exploring new targets such as LAX3, and the possibilities seem endless. But this raises an important question. When the scientific promise meet the clinical reality, what do the patients actually experience? So first, we need to understand that the immuno-related adverse events are fundamentally different from the chemotherapy toxicity. The long-term consequences include the endocrine issues like the permanent hypothyroidism and adrenal insufficiency requiring lifelong steroids. So survivorship now faces a new challenge, managing chronic conditions in patients who are living longer, and these conditions directly impact their quality of life. So then there's the issue of cost. Since 2011, new cancer drugs often exceed $100,000 per year. This creates what we call financial toxicity. Patients skip doses because they can't afford treatment. They suffer weight loss from time off work. They face even poorer survival outcomes. And this raises difficulty ethical questions. Who gets the access to these treatments and how do we ensure the equity? So the research significance are threefold: to empower the healthcare professionals with the insights and to break down the information barriers between the doctors and the patients, and finally to promote the patient-centric communication. Because the medicine doesn't just treat disease, the medicine also treats people, and NLP helps us to hear the voice from the patients.
Let's move to part 2, and we will talk about our data and methodology. And firstly, we look at the data pre-processing. And at the beginning, we have 5 million raw posts, and then we perform spell checking, correction, lemmatization to find their roots, and we filter them, and we also remove the short entry and the stop words. After these procedures, we reduce the data set to about 3.8 million text entries, and then it's the model selection. And here we tested 3 models. Model A is a general purpose model called Omni LM L6V2, and Model B is the bioclinical BERT, and Model C is the PubMed BERT, and Model B and C are for medical and clinical text. And here actually I said the number of topics should be 15, but the model can only generate up to 6 topics. And you can also see here are some meaningless words. So finally, we found the Model A performed the best, and then we chose the general purpose model. After that, after we chose the model, and it correctly identified clusters, but many of them were unrelated to immunotherapy. So to tackle with this, we filtered the domain. That means we design a custom domain keyword dictionary specific to cancer and immunotherapy. And then we removed all posts that didn't contain any domain relevant keyword. And after that, we reduced the dataset to about 2.7 million relevant posts. And then regarding our methodology, so for topic modeling, we use the BERT model to generate 24 different topics, and then we rule out the topic -1, which are just unclustered noise. And for sentiment analysis, here we used the transformer-based model because this neural network can understand some
difficult text, and then maybe you are wondering that why we didn't use like LDA for topic modeling, maybe also PCA for dimension reduction, maybe K-mean for clustering, or some tools like Vader to do the sentiment analysis. But we don't have much time to elaborate on it, and maybe we can go through them in the Q&A session. And then for part 3, it's our data analysis and visualization. And here we use the model to generate 24 different topics like this. And here we also created the topic word scores, and the topics can be mainly divided into 5 categories, and they are clinical and treatment, side effects, lifestyle and coping, socioeconomic, and finally the existential reflection. After that, we created the hierarchical clustering and similarity matrix map. And here we saw a clear divide. That means there are 2 different worlds in the patient's daily life. And the green part is the medicine cluster, which means clinical realities and physical pains. And the red part is the life cluster. That's the patient's mental fight to live a normal life and find meaning. And finally, our key finding is very simple. That is, doctors focus mostly on the green part, but actually patients spend lots of mental energy on the red part. And then we created the intertopic distance map and the documents and topics. And here we found that if we look at the center, we can see topics about physical pain like nausea. And so we can see the physical pain is a really shared common experience of every cancer patients. And then if we look at the outside edges, then we can see some lifestyle topics like reading, hobbies, and face, but they are spread far apart. So we can see every patient has its own different and personal way to cope with their illness. And then we check how the patient feelings changed over time. And firstly, we found that some outside events cause a lot of anxiety, and this shows very clearly in topic 9, which is about healthcare policies and insurance. And we will show the details later. And we also saw some quick bounce backs. That means sometimes the mood drops very low, but then it comes back up quickly. And overall, the long-term trend is really stable. And we can see over many years, most topics slowly become more positive. And to show this clearly, now I will demonstrate our interactive chart. And at the right side, you can click to choose the topics. And at the bottom, you can drag the timeline to pick the year you want to see. And here, I just chose the topic 9 about insurance and policy. And here, you can see that because topic 9 is very special because most physical side effects stay at a flat negative level, but topic 9 is the most negative and unstable topic in our whole data set. And you can see in 2015, the mood dropped massively. And this happened because of big political debates about healthcare insurance. And then the mood jumped back up in 2018 and 2021. And this gives us a huge insight that is money problems and healthcare insurance policies can cause more emotional trauma than the physical chemo side effects. And then back to our PowerPoint, then we look at the overall emotions here. Yeah, and firstly, we found a big surprise. That is, even though cancer is terrible, the overall emotion of the whole community is very positive. So why is it so positive? It's from like topic 12 about faith, and also topic 4 and 21 about hope and community support. So patients are really supporting each other, and what's the true hidden burdens? And we can look at the lowest sentiments. That is like topic 9. Which has the absolute lowest score. And also topic 5 and 13 are also very negative, and they are daily issues like nausea. And so here we can find that they make patients feel tired every single day. And this all for our data analysis. And I will not let Levin for part 4.
Okay, now we have just explored how real-world data sheds light on the complex experiences of patients. Next, we will examine the intersection of academia and practice, delve into what our findings imply for existing research and clinical practice. Traditionally, academia and clinical practice have prioritized acute, severe, or even life-threatening side effects, directly impacting the patient's safety. And we also widely use the standardized scales such as QLQ C30 as the cornerstone for scientifically assessing quality of life. However, through our NLP analysis of massive amount of real-world text data, we have discovered a striking contrast. Patients tend to complain more and express more negative emotions about long-tail side effects, those that persist over time and continuously impact daily life, rather than merely acute reactions. This suggests that focusing solely on acute toxicity may overlook the immense challenges patients face regarding their long-term quality of life. And on a deeper level, our real-world data also reveals the blind spot of the traditional scales. Our NLP model has uncovered deep physiological and social struggles like family guilt stemming from genetic risks. And this kind of challenges are what structured scale struggle to capture. And real-world data opens a window for us to understand patients' more complex and human needs. And then these insights promote us to ask, how can we translate them into concrete action? In part 5, we will propose 3 suggestions. First, we call for moving beyond narrative of tumor shrinkage. During follow-up visits, doctors should proactively inquire about non-clinical issues like sleep, diet, or appearance concerns. This helps doctors build trust, uncover those unspoken struggles, and provide comprehensive care. And for patients, true recovery means a holistic improvement of their quality of life. Second, regarding genetic testing, we recommend incorporating physiological and genetic counseling beforehand. Genetic reports are a double-edged sword, causing significant physiological distress. Therefore, when issuing reports, mandatory physiological intervention must be provided to help patients process the information, alleviate the family guilt, and maybe can transform the disclosure into empowerment. Finally, we emphasize the importance of managing long-tail side effects. For patients on long-term medication, we should establish sustainable community support and the lifestyle intervention mechanisms. Many chronic side effects, though not life-threatening, profoundly impact patients' lives. And these mechanisms can supplement the hospital care, improve the adherence and life satisfaction, and truly help patients live well and live long. And in the summary, our research advocates for a shift in perspective. Medical progress lies not only in conquering the disease, but also in understanding and responding to the patient's holistic experience as a person. As this quote states, medicine cures the disease, but it is life that heals the patient. Beyond the noise, hear the voice. Thank you all. And we are now open for questions.
Thank you very much. Thank you very much. We're very delighted to have Professor Yi-Ting Chen from the School of Pharmacy, Faculty of Medicine with us today. And please give your comments based on the student's presentation. Thank you so much.
So first of all, thank you so much. So I'm very impressed by the presentation. I always thought that, we deposit the data set into the repository and then it would just stay there forever until I retire or until I die. So thank you for reviving it. And I think your analysis makes a lot of sense. So first of all, can I ask which faculty are you guys from? Which program?
I'm from Faculty of Science, majoring in molecular biotechnology.
Okay.
I'm from Faculty of Science and I'm majoring risk management.
Right. And
social science.
all right. Yeah.
From the SPS.
Yes, I'm really glad that non-medical students, non-healthcare students from non-healthcare program have a chance to touch this data set. And I love it, like what your conclusion is that medicine is not just about treatment, it's also about the psychosocial, the psychological aspect. All right. So I do have a few questions, but because of time, I will just ask my burning question. So we faced a lot of hurdles with analyzing social media data, even though like social media is part of real world data.
data. Okay, so one of the barriers is that with NLP, with analysis of unstructured data, can you tell us what are some of the barriers that you face, and why did you think we use BERT topic as the approach to analyze the data?
Yeah. Okay. So firstly, why we choose the BERT? Like the traditional method is to use LDA, but LDA is not a transformer based, and it's a very old and traditional tool. So it maybe cannot analyze some difficult, complicated text. And then we choose the BERT because it's transformer based and it can understand the text better. And also, like for some other pipelines, like we choose to use the UMAP for dimension reduction, and we choose the HDB scan for clustering in the BERT itself. And for the sentiment analysis, let me see. And for the sentiment analysis, actually, there are some traditional tools like Vader or TextBlob, but they are also really old and they are not transformer based. It maybe cannot also cannot understand some complicated things. So finally, we also choose the transformer based model that is Robert A for the sentiment analysis. And so these modern models can better understand the real world text. And also there are some barriers that because the data set is too large, it firstly contains 5 million posts. And even after the data pre-processing, we still have 2.7 million. So here, firstly, we just chose a sample that contains 200,000 posts and to train the BERT model, and we let the model to generate 24 different topics, and then we use this already trained model to check the topics of the every 2.7 million posts. We think the most difficult barrier is that because the data set is too large and we need we need a long time to process on it. So like we finally become a Colab Pro Plus and to use the better GPU to process the data. Yeah.
Excellent. Right. So, I mean, one of the main reasons why we use BERT topic, because analysis of this sort, one of the major criticism is that we are just looking at, words, text and all that. So BERT topic that has more, we call it semantic awareness. So, I mean, most of us, we play with social media, we know that, if I say like, example is Miss Ching Ching, 我真係恭喜你啊. So this is I don't mean well, right? 我真的恭喜你啊. In Cantonese, like, I don't mean well at all. Okay, so I mean it's the same problem with text like this. So what BERT topic does is it has more semantic awareness. So you look at the context, the other words surrounding that post, and to determine the semantic analysis. All right. Maybe second question is, what kind of ethical considerations do you think we have to take into account when analyzing data like this and reporting data like this? What ethical concerns? I think we have mentioned about mandatory physical intervention, and this maybe the doctors or the hospital should ask if the patients would like, if they are willing to do this. But our suggestion is more like about we'd like to change it into a clinical procedure, like also some physical condition check. We'd like to put this part into the normal procedure when the cancer patient or other kind of patient when they're entering the hospital. And also the hospital will tell the patient that because we want to empower the patient's knowledge, like the doctors or the hospital will give back the initiate back to the patient to tell them why why you will have this kind of side effects, and because sometimes side effects means that he's recovering, and that is not a bad news. So I think the patient will accept that.
Okay, thank you.
And also, there may be a concern about the data privacy, and because even the data was sourced from the public forums, but actually there are not much privacy information in the data set, and we just use the topic modeling model and sentiment analysis model to check the topic and the emotions. So actually, it's not really relevant to some personal privacy.
Yeah, so important thing to know is that, we perform web scraping in order to extract the social media posts and from blogs, but we need, although they are open access, open source data, we still have to be careful. We need approval from certain organization or blogs in order to do that, because the backend scraping, sometimes you may scrap the patient's or the netizens' personal data, and when we report, we may have the sometimes we may have the tendency to report their quotes, right? To quote them in our report, but we have to be careful, because sometimes by tracing the code, we can trace back to the person's identity. So when we reported the quotes in our publication, we have to rephrase that. All right, so thank you so much. One last comment, and I think it's impressive that we didn't think of analyzing the themes by time. So I think you did a very your interactive program that, you measured over time, over years, what are the common themes and how much they are reported. That is something that we didn't do in our original report. So thank you so much. But of course, and one point is that, that will only reflect ecological relationship, not so much the exact association. Like, I know you try to correlate the health insurance, the differences in policies with what you observe in the trends, but that is more like ecological association. So I think it's more hypothesis generating rather than conclusive, but that's a really good exercise. So thank you so much for using our data set.
Thank you. Thank you.
Thank you again for our fourth group. And let me invite the fifth group, AC group, Renxing and Yingke, to come forward, please.
Okay, so good afternoon, everyone. So we are AC group, and I'm Chris, and this is my groupmate, Athena. So our project is titled The Reading Between the Reels, a data analysis of a city entertainment magazine from 1979 to 2007. So the city entertainment magazine, we know in Chinese as 电影双交刊, was one of the Hong Kong's most influential film publication. So here are the quick overview of what we will be covering today. So first of all, we will start with an introduction to the data set and explaining the problem we set out to solve and objective we designed for the projects. So we will offer all our methodology and explain why we chose each approach. So from there, we'll move into three main analytical sessions. First is a dynamic visualization of offer ranking over the time. And second is an analysis of how magazine topics shift across 3 decades. And finally is our experimental analysis using the food reference as a culture mirror to track out how Hong Kong identity evolved. So let's begin. So this magazine is found in 1979, was published bi-weekly until 2007. So we think that which spanning the full arc of Hong Kong cinema golden age. So in this magazine, they will cover the film, the television, the music, the celebrity culture, and also the social commentary. So let's take a look at the data set. So after our calculate, there's almost 25,000 articles across 8 editorial categories and 3,600 unique offer from prolific staff writers to one-time contributors. So before we move into the analysis, let's take a look at how the 25,000 articles are contributed across the editorial categories. So the classification system we build assign every article to one of these 8 groups is first one is the magazine structure, the film criticism, the film studies and theory, the interviews and profile, and industry and market, production and technology, television, and other performing arts. The final is the cultural commentary. So the most striking findings here is how dominant the cultural commentary is at around 35%. So it accounts for over a third of all articles. So this tells us something important about the magazine characters. So it wasn't purely in the film review or publication. So it's a huge proportion of its content was broader cultural observation and social commentary. So the film criticism and the industry and market each accounts around 16%, forming a second tier, and the other end, the film study and the theories, production and the technology are smallest categories, together making up less than 3% of all content. So this distribution sets of the foundation for everything that follows. So keep those this proportion in mind as we move into the analysis. So now Athena will talk about the problems we define and the methodology.
Let me begin by walking you through our research problems. It's what can 25,000 articles tell us, and more importantly, what traditional analysis cannot tell us, and why it matters for understanding Hong Kong's cultural history. First, it's about the author contribution data. We know the names of everyone who wrote for the magazine, but this data has never been visualized dynamically. We know who wrote, but we don't know when their influence rose to prominence, when it peaked, and when it eventually passed to the next generation of writers. And the second problem is about the large scale of the corpus, because no single readers, no matter how dedicated, can read through all of these materials and detect how the magazine's editorial identity shifted at scale. The topic patterns across decades, like the gradual rise and fall of certain themes, are completely invisible. So, in other words, you might sense that something changed, but you cannot measure it quantitatively. And the third problem, and perhaps the most interesting one, is about food and everyday life vocabulary in the corpus, which has been almost overlooked by researchers, because film scholars focus on films and cultural critics focus on criticism, but nobody has to look at what people were eating, drinking every day. Yet this everyday vocabulary may encode the most honest signal of how Hong Kong's cultural self-image changed over 3 decades. So, what do we want to achieve? Our core objective is to demonstrate that open humanities data combined with computational methods can reveal profound insights. So here are 3 concrete questions and 3 analytical directions. The first objective is about to visualize the dynamics of the author community. We want to see who dominated each era and who faded away, and exactly when influence changed hands between generations of writers. And the second objective is to identify the latent topic structure of the corpus and track how topic proportions shifted from 1979 to 2007. And the third objective is use food vocabulary as a cultural proxy by measuring how often certain foods appear from local to national, so we can track the magazine's shifting cultural register, like was it becoming more local or more international? The food words can tell us about this. To achieve the 3 objectives, we began with some data collection, cleaning, and pre-processing. So for the author dynamics, we counted article frequencies per author per year and created 1 dynamic visualizations, which we'll show to you later. And for the topic shifting, we used a technique called BERTopic, and this is an unsupervised machine learning method that scans all the text and groups words into topics based on how often they appear together. The algorithm doesn't know what a film or a criticism means, but it just finds statistical patterns in words, co-occurrence. So this allows the machine to discover the magazine's hidden taxonomy without us telling it what to look for. And we don't choose the traditional TF, IDF, or LDA because they treat text as bags of words, so they miss meaning or some sentimental context. And this method per topic can use sentence transformers to embed each article as a 384-dimensional meaning vector, which semantically similar articles can cluster together regardless of exact word meaning. And the PCA method is added as a second lens. It can compress 384-dimension vectors to 2-dimension vectors, which can visualize you how the center of gravity drifted across areas. For the third objective, food analysts, we built a custom lexicon of food-related terms in Cantonese, categorized by 300 specific food terms related to 26 regular food types, like drinks, seafood, Japanese, local street food, these food types, and then track their frequency over time. Now let me explain in more depth why we choose food as a focal point. Food vocabulary serves as a proxy for cultural register and everyday life. And food references are deeply culturally specific because when people write about what they eat, they reveal their identity and their aspirations and their social world without necessarily intending to. So food words are historically sensitive. They can change as the city changes. So we choose the food precisely because it offers a non-obvious cultural signal and one that traditional film scholarship focused on directions and box office numbers and some numerical data sets would overlook entirely. So we think this is reading between the reels, literally. Now let's look at our first set of findings. This animation shows the top 10 most prolific authors in City Entertainment magazine. And the first thing you will notice is how stable the rankings are. And some core groups of writers consistently letting output across all 3 decades, suggesting the magazine realized heavily on a dedicated long-term editorial term. And interestingly, Zilius, meaning the editorial department, consistently ranked first. This tells us that a large share of articles were institutionally produced without individual bylines, which reflects the house-style editorial culture common in Hong Kong magazines. Finally, while new authors did enter the rankings over time, they rarely displaced the veterans. This points to a magazine's culture that valued continuity and long-term contributor relationships, which is quite different from today's media landscape where voices could change rapidly. And now let's turn to what they actually wrote about. We applied per topic to the entire corpus and let the algorithm discover the latent thematic structure without our guidance. The result was 22 distinct topics, which together reveal the magazine's hidden taxonomy. Look at the largest topic is about commercial cinema distribution. And of course, this is an entertainment magazine, so it covers the business sides of cinema. But now look at the third largest topic is music and recording industry. This is a surprising finding because this entertainment magazine was a film magazine, but here we have quantitative proof that it was broader than that. It covered the entire popular culture landscape, like music, recording, and business of sound. I also mentioned that we identified 2 noise topics that were removed from further analysis, like the fifth 15th topic is consisted almost entirely of copyright, and the 17th topic was business address listings. This brings us to our core finding about how the magazine changed over time. What you are looking at is a PCA plot showing the semantic or center of gravity of the magazine's discourse across different periods. Each dot represents a specific time slice, and the distance between dots reflects how different the topic mixtures are between those periods. And this visualization reveals a dramatic structure shift in the magazine's editorial identity. So for the more specific content, let's see the magazine's phase across 5 eras. First is during this year's mass entertainment content rose steadily alongside Hong Kong's commercial boom, and the economy was thriving. Like cinema attendance was high, and the magazine expanded its coverage of popular films and stars. Second is about the television media surges post-1997. This reflecting the rise of cable TV in Hong Kong daily life. And third is about like 2000 and 2007, this era as more warm pays inform. And now let's look at our core finding about popular entertainment peaks and then collapse post 1999. This because the audience fragmented, and so did the magazine. The rise of cable television in Hong Kong and the influx of Hollywood blockbusters and the growing probability of Japanese anime and the international content. All of this put readers in different directions, so the magazine could no longer be a unified voice for a unified audience. Its editorial identity shifted.
So thank you, Athena. So now we can see some analysis I put on the food analysis. So first of all, these bubble checks look at the food mentioned across all 9 articles categories simultaneously. So the most surprising finding is that the industry and market articles, not interviews or cultural commentary, have the highest food mention density at almost 0.6 words per article. So this suggests that the film industry reportage was deeply embedded in Hong Kong dining and the banquet culture. So the business was done over food, and the writings reflect that. So the cultural commentaries tells us totally different stories. So it dominates in the total food word counts with nearly 3,000 occurrences, but it drives by the volume, not the intensity. So this simply far more cultural commentary articles than other categories. So the numbers add up even through each individual article in some particular food heavy. So the key takeaway. So the key takeaway of this bubble chart is that the food language in the articles wasn't random. So it follows by the writing style and the social context of each article's type. So these charts compare the top 15 most mentioned food words across 3 decades, and the 3 clear cultural shift emerged. So in the 1980s and the 1990s, the coffees, you can see that was the single most mentioned food item by significant margin. So reflecting the cafe culture, but surrounding the Hong Kong's film industry. So by the 2020, the chocolate has overtaken it. So pointing that a growing influence of the Western desert culture. So finally, I have also built an interactive workout for food. So this workout visualizes the top 100 food and drinks found across all the articles. So if you have time, we can take a look of the food workouts. So when you point your mouse or hand over any words, you can see the English name, the total occurrence, the peak decades, and short description of what is present in the magazine tells about the Hong Kong food culture at the time. So at the end, so to bring together the 3 mentioned, the 3 different lenses, but they told us the same story of those data. So what leads us to our core takeaway is that the City Entertainment Magazine is not just a record of Hong Kong cinema, it's a systematic container of city cultural identity. So all code and our data will provide later in our poster. So thank you.
Thank you. Thank you very much for the AC group. Just click on the full screen there. Thank you. Do you have any questions for this group? Okay, if not, I would like to invite Ms. Kitty Sui from the CUHK Library's Digital Initiatives team to give some comments based on the student's presentation. Thank you so much, Kitty.
Thank you. Thank you, the AC team. I think the most interesting part is on the food. Proving that you're from Hong Kong. Okay, but one thing to remind you that for the film critics, not criticism. Yeah, it should be film critics. And then I don't have much to comment actually. But I would like to know more about the slide 13 on the shifting. You have a table. Can you explain? No, not this. I did this one. Can you explain a bit more on that?
Sure. This color is about the frequency, the count about the topics in each areas, and the more like the red color and yellow color means there are more contents of the specific topics. Like you can see the 1990 to 94, this era, we have the red color in the like this one. And this can reflect in these areas. These magazines are more about the daily life.
Okay, so may I know how you arrange these topics, just by random, or you have any special meanings?
Well, this topic is follow the like the order of the topic 1 to 22, and this was the order of the per topic method. Okay. So like that's the order they extract from the data set, but not with the frequency like this one. This is ordered by the frequency, like there are almost the first is the largest and the second is the second largest. And for this order, this is about the per topic method extract order.
Okay. Okay, thank you. I don't have more comment on that.
Okay, thank you. Oh. Thank you. Thank you again, Kitty. Okay, we have another comment from, is it Vincent? Vincent, thank you.
I think you should pay more attention to the meaning of word for the food from your food vocabulary. For example, 豆腐. I think is another meaning. For example, 我食你豆腐咁你即係其實即係佔你便宜咁樣，即係可能 not reflect to the food trend of the cultural. And also another example, 豬扒咁 is yes. Or maybe an adjective, not truly reflected in your food trend or the cultural mirror. So I have some hesitation if you use this word to reflect your cultural trend in your studies. So I think you need to read through the full text again to see what is the meaning of this word. Because it will define another level of sentiment or emotional bank.
Yes, for those situations, actually, we have think of it before. So if you have take a look of our code, so to prevent those cases, we have already checked each foot the +2, the 2 word before and the 2 word after. So to check the connection between whether this foot is actually meaning is like 豆腐, and I食豆腐, the 豬扒. So after the checking before the 2 works and after 2 works, so we have found some accident of it. So we have to prevent those accidents, so we apply this method. So to ensure that the food we extract is exactly the same meaning of the food itself.
Great, thank you. Any more questions or comments? If not, thank you so much again for the AC group for your presentation. Thank you. So let me invite our last panelist group, our 6th group, Qishu, Yushen, and Miao. Please come to the front, please.
Very good morning, distinguished guests, all participants. We're Team Twitter Go, and today our topic is about the information diffusion and social network analysis. So to give an overview of our presentation, we will first introduce our topic and our research objectives, and we're going on to discuss about the data structure, and then we're following to analyze the user clustering and the strategy, and in the end, we'll go on to real-life applications. So we first start with the major question of this topic is what drives deep diffusion? To solve this major question, we divide into 3 sub-questions. The first one is diffusion shapes. We identified there are 2 main diffusion shapes based on this data set, which is broadcast and viral. So we will go on to discuss more about the differences between these 2. And then what follows next is the behavioral mechanisms. We'll talk about how intersimilarity and all these factors influence retweeting behaviors. And in the end, what matters most is how it would be adopted to real life. So we will talk about how actionable interventions from platforms or brands could utilize all of our research. So let's start by talking about the first sub-question, which is diffusion shape. So let's get into the dashboard. So we've formed different propagation cascade throughout the data sets, and there are in total 966 cascade per graph, and overall there are 257 broadcast type, 189 viral type, and as you can see, they vary very differently regarding to the maximum breadth, which means the maximum user they reach in a certain layer, and they are very different in terms of the depth and the structural variability. So we could take, for example, to see how each matrix looks like. So we first start with a sample of viral. As you could see, this is an example of viral. That means starting from the root follower, the orange dot, it will go very long in depth, but as you could see in each layer, it doesn't have that much of spreading. And we will go back to see another example of the broadcast. So as you could see, unlike the first graph that we see, the broadcast, they have a really maximum breadth on the first few layers, which indicate the differences between these 2 is that for broadcast type, they might be the big KOLs. So that means they're retweeting percentage is very large at the first few layers, and for those with the viral type, they probably would have not that much of influence on the Twitter, but they have quite a high community impact, so they would also go very deep in depth. So we'll go back to our slides and walk you through a very practical example is that, for example, if you are the marketing manager at PopMart, 5 years ago, the designer toy collection is still a very niche topic. Not much people know about it. So the key question you're concerning is on this platform, how should you let more people know this topic? How do you cold start it? And we identified this problem through 3 metrics. The first is visible immediate action, how many people immediately see it. And the second is bridge between different communities, how much people outside of this niche community want to get to know more about it. And the third one is in-depth promoter, which means like how deep you could go on through it. So we did the clustering through our data set, and we identified the users into 6 clusters. We did the cluster based on 2 main category of features. First is mechanism features like intersimilarity, structural redundancy, all of that. And the second is skill mechanisms, which means that how much followers, like how much volumes of following followers are occurring by this user. So as we identified, if you want to cold start a project, you might go for the first cluster, which is exposure rater, or you could also go for the sixth cluster, even though they don't have a very large visible immediate action, which we talk about as A, but they are very active in promoting it to the depths. So what we derive from it that could adopt to real life is that first you need to think very carefully. You need to think very carefully about what is your promotional goal. Think about the topic. Are you consumer goods or are you a Web3 topic or something? What kind of target audience you want to reach? And then second, you need to analyze the budget because you don't have the money to afford all of the big influencers and KOLs to do the broadcasting. And the third one is you should choose the right promoter. As we say, there are broadcast type and viral type. You probably want to find some new rising stars instead of the big influencers to reach the first layer of audience. So now I'll hand on to Dora to talk more about behavioral mechanisms.
Thank you, Serena. So after generating some graphs and charts about the business strategies, we further validate these data and our insights through different models. So as to start with, the major tools that we use are R language and Python in our programming. And for our source paper, we mainly focus on, firstly, cleaning and extracting the data from different column names from the source data table. And then we refer to the original graph or the propagation structure offered by the source paper. So thankfully, the paper mentioned about the idea of seed user, that is the root node, that the starting point of the diffusion process. And as you can see from this layer, this chart is similar to what Serena showed you. It's like a diffusion process where the depth represents the layer of diffusion that has been experienced. And we focus on mainly three things: the relationship between parent user and the retweeter itself. Secondly, it's about the structural redundancy and its noise role in our programming progress. And the third thing, the most core mechanism, is the relationship between the intrasimilarity and how the diffusion pattern works in a dynamic way. So a basic thing about our methodology is that we mainly use statistical model in our programming process. It's mainly about the binary logistic regression on a multi-level sense. And the first thing to start with is our macro analysis on how the intrasimilarity and retweeting behavior acts in a correlational way. So this part is mainly focusing on the common sense part. So as we expected and as a source paper pointed out, the general relationship between intrasimilarity and the retweeting behavior is that the more users share this common interest, and the more likely they are willing to retweet on their parent user ID's content. However, we found that the statistical differences between these two types of diffusion, that is the deep type and the wide type, are not that significant regarding their numerical appearance. So we further dig into how the threshold of intrasimilarity affect the conversion or the further spreading of the propagation to sustain this diffusion process. So here is a descriptive graph for the attenuation of intrasimilarity as a depth growth. So first of all, the green section represents the knots of the diffusion process, which means the number of users involved in each diffusion layer. And the blue parts represents the about 97% of the confidence interval for this investigation. So the thing that we focus on is as attenuation trend goes on, we can discover that generally at the earlier stage of information diffusion, homogeneity is the most important thing in deciding on the retweeting probability. However, this graph is only a macro level and rough prediction on the result of diffusion. So we further investigate in different windows of this diffusion process. So we chose the layer from 1 to 4 according to the data cleaning results. And we found that the marginal impact of intrasimilarity on retweeting is actually decreasing. So why why does it fades? Why does the influence of intrasimilarity fades? Our societal guess is that from the point of sociology, the funnel effect may be a point, which means the people's attention from the core information itself gradually increase, and the attention on whether their shared followers or shared social relationships also act in this retweeting behavior actually is reduced. And finally, we validated the phase-based propagation pathway. So from this graph, you can see that the blue column represents the shallower depth, and the red column represents the deeper depth. And for the deeper ones, you can see that although they share optimal similarity threshold that is similar to the shallower diffusion process, however, their conversion lift about the threshold is higher. So this raises a point, a very nice insight in our investigation. We discovered that this is actually something that against our common sense, because previously we mentioned that we found the intrasimilarity reduces but still act significantly in the diffusion process. So why does this contrast in our data show up? We believe that this might be due to a sense that the interest similarity becomes a scarce signal as the statistical process move on as the depth increases. So here's a real-life example to help you interpret this situation. Imagine you are a HR staff in a company and you are hiring undergraduates from CUHK. And at the earlier round of application, you may receive most CVs from students with relatively high grades. So they want to send out their CV at the earlier stage. So at this time, high grade is not the major thing that decides whether you will provide them offers at the last minute. However, as in the second round of application, you might receive CVs from students with a wider range of grades. That means their academic academic behaviors will be more diverse. So in this sense, the high grade might be scarce. So among these students, the most important thing that make you decide on offering their job position might be the high grade itself. So in this case, the high grade represents the intrasimilarity in our investigation. So that's how the primary diffusion stage and secondary diffusion phase different. And another thing is that we feel that it's a pity that the source paper did not mention about the content of the retweeting posts. So if we can have more information about the content itself, we can do more investigation on high-dimensional analysis on the spatial aspect of these data. And another thing is that we did not focus on the structural redundancy section because they gradually become background noise in the logistic regression analysis. As a depth increases, the structural redundancy becomes insignificant with regarding the difference on the parent users or the retweeter users. So now we'll move on to how this lead to some social impact.
Okay, so let's start with what companies already do today. And for advertisers and merchants operate with linear funnel, their goal is GMV, leads, roads, and behind this is a basic mental model. More clicks lead to more conversions. So basically, what they're doing is to change impression into click, into sign up, and eventually get their pay. And with this optimal goal, we can separate this into three functions. The first one is user growth teams. They focus on metrics like CAC, LTV, and activation. So basically, their main focus is to harvesting demand, finding high-value users through repeatable mechanisms, and they ask what channels consistently bring in good users. And the second one is user operation teams who focus on segmentation. So they separate high-value users from dominant ones, match contents to each segment, and then they build a life cycle onboarding to reactivation. So the basic goal for them is retention and activity. And finally, there is creator and KOL operators. So they are facing what we call the tier problem. You have top tier creators with huge reach but high cost, and mid-tail creators with strong ROI and relevance, and emerging creators with high upside but more risk. So the challenge is the budget allocation usually follows reach, not propagation potential.
So here's the current toolbox, and what we are suggesting is focusing on diffusion structure strategy. So traditional metrics don't tell you if a user is a dead end or a bridge to layer 2, 3, and 4. But through our research, we've learned that looking beyond impression and understand cascade depth, this means tracking how contents move from seed to step 1, depth 2, and eventually to the further depths. So we've identified two key amplifiers. So the cluster 1 is the core amplifiers who with embedded user, high similarity and redundancy. So those are the one who triggers cascades. And then there's cascade 2 with participants. They actively post, but given their weak network leverage, their posts just spread shallow. And so based on the distinction, we can have a layered playbooks for to offer different designs for different depths. For depth 1, we offer broad appeal, low barrier contents with strong effect, even with low similarity. And for depths 2 to 4, we can offer them high match, high value content, which requires higher similarity thresholds to sustain the lift. And here's the clearer picture. So what we are proposing is the propagation engine with the strategy to optimize for conversion and ability to propagate at the same time. So the matrix we are using is depth metric from D1 to D4 as long as the cluster rolls, and the outcome we are expecting is cascade health and lift. So with this engine, we can diagnose why similar campaigns, some dies and some spread fast. So here are 3 detailed suggestions for different faculty. So for growth, okay. So basically for growth and user ops, the key suggestion is to changing the decision. And for creator and KOL operations is to move from follower count to consider who systematically trigger deep and multi-layer diffusion in your audience clusters. And the key findings are basically listed there. So in summary, our suggestion is to shift from a strategy based on outcomes to a strategy based on how outcomes are generated. So here's the end of our presentation, and we are now open to any questions. Thank you.
Thank you very much for your presentation. Any questions for this group? If not, I would like to invite Professor Liang Hai, the Director of School of Journalism and Communication, to give a comment based on the student's presentation. Thank you so much for coming, Professor Liang.
Okay, thank you very much. It's very interesting. I never expected someone will read my paper. So, yeah, it's a very technical one. So if you read the original article, then you'll find it's a little bit complicated. I share the studies in many conferences, and I guess that nobody want to ask a question. Okay, today I supposedly come here to ask questions, but you know, even my audience didn't propose any questions. It's really hard for me to propose any any question, but I just want to try to share some stories with you. So first of all, so the original article, in fact, was rejected by more than 10 journals before its publication. So most of them are just a desk rejection. I'm not sure that how many PhD students here. So you can imagine that as even, I guess that I'm one of the very productive ones. So even in this case, I was rejected by many different journals. The reason is things that it is too hard to understand. So, but today's presentation that make it much easier. So, and even with a lot of beautiful pictures that you just much better than mine. Okay, so and the second is I didn't at the very beginning I think that my interest is about a social network analysis. So I'm typically interested in the dynamics. So the second part, I don't even know that there is any marketing implications. So I know this is in fact this is a quite a popular areas even in academic research in the business school. So they are doing something similar, but it's the purpose are quite different. So next, the viral and broadcasting. So for me, my interpretation, okay, so you need to be sometimes different from yours. So the first one is that you will find that in fact in the marketing practice you will find that actually the easiest way is for broadcasting instead of to try to create a viral one. That is nearly impossible sometimes. So because the study just imply a lot of correlations, I don't know. So I know some kind of a cascade will become viral and with some certain characteristics, and but I don't know why even. So, and I even know, so if it's a viral cascade, that which means that it's spread in a step by step through many different steps that finally will reach. You will reach some audience quite different, some users quite different, very diverse users. Instead of there's all the follower of a single one. Okay, like you watch TVB and all the audience of TVB, that is quite similar to each other. That's why you follow TVB, okay? So, but if you want to reach some quite different users, the viral one, that will be a good one. But the problem is that, and probably is just because, okay, the rich, diverse audience, and then it becomes the viral ship instead of the viral one created the diverse audience. So I'm not so that confident about the marketing implications. Okay, so third one, so I'm also the director of the computational social science lab. So probably you know that we have a quite similar course, the computational social science seminar. So that for PhD students only. We do replication as well. So we have a rich experience in that part. So when someone tell me that they want to replicate in my study, so you know, so I was a little bit nervous. So because based on my experience, okay, in the we run that course for already several years, and every year that we pick some very popular articles published in Science, Nature, PNAS, and whatever. So the perfect replication, the rate for perfect replication is just zero. We never can completely replicate all the findings from the original authors. So that's why I'm nervous. You will find a lot of problems. Okay, probably this is my question. Did you find any problems in the data?
Oh yeah, thanks, Professor Liang. So, thank you so much for the insight. And we want to mention about why we link this to the marketing, because we think for information diffusion, like who would care about this question most is people who want to get their topic reach to their target audience. So that's why we bring this topic. And for the second part, as you mentioned, why it's for the viral, like nobody predicts how the things got viral. And we agree it's a very difficult topic. And we have also done research and asked other professors regarding this topic. And I think what Professor Liang you mentioned is a more deep question called influencer maximization. And it needs more data from the data set. For example, the two KOLs for their followers, do they have a lot of intersections? Probably they're all very popular in this, for example, like finance field promotion, but their target audience, but their people who read their tweets are like 50% the same audience. So in that sense, using the money to let these two KOLs to promote at the same times is honestly not a good idea because you reach repetitive audiences and you're wasting money. So we probably need that metrics in the data sets if we want to go on deeper into talk about what makes it viral. And on the other hand, because the data set we get is the data that's already being cleaned and pre-processed, as you could see from our raw data set, there is a lot, already a lot of metrics like information similarity, number of exposures, and like this. But this is unlike other data set, this is not the original tweets, which means that we don't get the original tweets. So if you want to predict whether a tweet has the potential to be very popular, you probably need to get deeper into what this tweet is about.
and who exactly this person is. Like, for example, if it was an expert in AI and versus a new rising star in AI, their influence is significantly different. Like, just like someone who loves AI versus Sam Altman, their influence is definitely very different. So we would also need the exact probably information on the KOL and the exact information on what is the tweet in the data sets in order to achieve what you said, to investigate more on what makes it viral. Thank you.
Thank you. Any further comments? Or it's okay?
Can I add something about?
Oh yeah, sure. Please, yeah, go ahead.
So firstly, I'm grateful that this paper is published. Thank you for offering us this precious source paper, because like personally, we're from different faculties, not even related to computer science or data analysis. Like personally, I'm from life science faculty. So I believe that this paper is precious because we chose it partly because it can be conducted in a paradigm shift context. So we can shift the pattern of diffusion and use this mindset of analysis in other fields, like the public health, because the viral diffusion patterns actually also like reflected in the information diffusion. So I think the flexible mindset here used is really precious for this the undergraduate stage training. And another thing about your question about the limitation in the data is actually platform-based, because we noticed that in the early stage of our investigation, the Twitter platform is different from platforms like Weibo or like the Little Red Book used in the mainland. It's like the information type and the content retweeted in the Twitter is quite different across different fields. So I can get why the source team did not choose to like post all the detailed comments involved this Twitter. I think the written content will be a large volume to investigate. So maybe in the future, if we still got chance to do something like data hack or such statistical analysis, we would like to explore more on like how the specific topics of the retweeters and the users have used will affect the diffusion pattern. So thank you for your question and your precious source paper.
Thank you. Thank you very much. It's very good.
Thank you. Thank you. Thank you. Any further comment? Oh, no? Okay. Thank you very much again, Professor Liang, for coming for your comments. And thank you again for our students for your presentation. So, in the interest of time, we will have to end our sessions here. My sincere thanks go to all our student presentations for your excellent presentations. I think we're so proud of you for your achievement in a short period of time. Just FYI that the group actually just started beginning of February, so a little under 2 months. You guys have accomplished a lot, and we're truly proud of you. Congratulations again for all your great work. I also would like to extend our thanks to our invited reviewers for your valuable insights and thoughtful comments on the student presentations. So this now brings us to the conclusion of Data Excellence Week 2026, organized and hosted by the Chinese University of Hong Kong Library. We're truly grateful for all your participation and support throughout this week. Now, I would like to invite Ms. Lily Kong, Head of Research and Learning Support, to deliver closing remarks for the Data Excellence Week 2026. Thank you very much, Lily.
Thank you. As the lunchtime is coming, so I will deliver very short closing remarks. First of all, I want to thank all of you and all of us to participate in the whole week. We have 5 sessions organized for the Data Excellence Week 2026, 1 session per day. And we have invited experts from South Africa, the United States, and Chinese mainland to share with us their insights and what's the best practices in the research data management during the week. At the same time, we have 2 wonderful students initiatives. The first one is the Data Champions in Aggregation Ceremony. And the second one is today's session, final presentations of data analytics practice opportunities. So all of you did a wonderful job because you can did what you have done today, show us in a very short period of time. So we are very proud of you and thank you very much for your hard work and delegation. And then during this week, we have a lot of sharings and also have wonderful sessions to discuss and exchange ideas. We hope that after this week, with the conversations or the dialogues, we're still moving on. Finally, want to say thank you very much to all of you who to be our speakers, our panelists, reviewers, coaches, and all the colleagues behind the scenes. So this is a wonderful week. Thank you very much, and let's celebrate and have a relaxing time later. Thank you.
Thank you. Thank you. Thank you so much, Lily. I would also like to thank all my colleagues here at the CUHK Library, as well as members of the wider CUHK community for your tremendous support in this week. So we truly hope to stay in touch with you and seeing you in our future research data related events and initiatives. For in-person audience, please stay behind for lunch. And thank you everyone again so much for coming and for participating in this Data Excellence Week 2026. So enjoy the rest of the day. Thank you. Bye.